morning, scholars. I hope you're doing well. Let's get started with our math lesson for the day. So before you do this math lesson, this is the math lesson for Wednesday. It's module 5, lesson 6. Before you get started for this, please stop, go do your application problem right here, because this application problem specifically should be very helpful with the math that we're doing today, because we talk a little bit about what it looks like to kind of separate two rectangular prisms that are put together and how we can find the volume of them by separating them. So if that sounds a little confusing to you, go check out the application problem. I think it'll really be helpful. So today, our objective is to find the total volume of two non-overlapping rectangular prisms. That's got some big vocabulary in it, but basically what it means is find the total volume, you know what that means, find the complete volume, the amount that fits inside, of two non-overlapping. Non-overlapping means they don't overlap. They're not like this, they're like this. They're touching, but they're not overlapping. Rectangular prisms, you know what that means, right? So basically what we're looking to do here is figure out how we can find the volume of something like this, right? So if you'll notice, right, we have sort of these two rectangles. We have what we could call the blue rectangle, right on top. Here's one rectangle, and then we have, let's make it orange, the orange rectangle on the bottom, and together they would be sort of one whole shape, right? And so the question is, if we called the whole shape, let's make it this purple color, if we said the whole thing, I'm going to do sort of a rough outline here, was this purple shape, what is the volume of the purple shape? In other words, what is the volume of the blue shape plus the orange shape? Because the purple is the blue and the orange put together, right? That's what we need to find out. That's our question. The volume is what? And in order to do that, what we're going to do is we are going to start by separating out the two rectangles. We're going to look for the volume of the blue rectangle and we're going to look for the volume of the orange rectangle. And volume, as I hope you remember, is length times width times height. So let's start with our orange rectangle here. What is the length of the orange rectangle? Well, I see a 3 up here, and I see a 6 down here. So if you notice this 3, it shows, it's got like a little arrow, and it sort of ends here. And so this is not the length of the whole orange rectangle, it's only the length of part of it. I need the length of the entire orange rectangle, right? So I need all of this length, or all of this length. And that would be 6 inches to be exact, right? 6. Now, if I look for the width is 5, right? 6 times 5, and the height is, well, I see a 2 and I see a 4, but if we sort of take the blue away and this orange away for a minute, you'll see that the orange only extends to here, and the 4 inches, that's 4 inches, right? If I go above that, that's getting into my blue rectangle, which is not what I want to do. So my height is 4. So now I can do this. 5 times 4, that's 20, times the 6, that's 120. So I found the volume of my orange is 120 inches, I'm gonna say inches cubed, right? That's the volume of orange. Now we've done that, now we need to find the volume of the blue rectangle. So in order to do that, again, I need my length times my width times my height. Now this might be a little more tricky because if I'm looking for length, I can see that there's this 3, and again, the 3 extends, the 3 inches is showing that it goes from here to here, which is exactly how long my blue rectangle is. So the length I can find. The length is 3, right? Now I need to find the width. And if I'm looking around this blue rectangle again, I don't see a width. I see the length, but there's nothing, if this is width, there's nothing that labels the width. So I want you to take a minute and I want you to look around at this rectangle and see if there's any way you could figure out the width. So pause the video, take a second, and when you think you have an answer, come back, right? So what it turns out is, if you'll notice, this rectangle goes, the width is exactly as long as the orange rectangle below. In other words, the blue rectangle doesn't just extend to here, with the orange rectangle extending to there. The blue rectangle doesn't go further out than the orange rectangle. It goes exactly the same width as the orange rectangle. And the orange rectangle, we did get the width. It said that the width was 5. So the blue rectangle is going to have that same width. It's also going to be 5 because we can tell that they're the same, right? So like an example would be, if I know, and this is not true, but like let's say I know this marker is 6 inches long, and I don't know how long this marker is, but I know that they're exactly the same length. Even though I started out not knowing how long this one was, I can infer that it's also 6 inches because I can see that they are the same height. So with that, I'm able to find the width of this blue. And now when we look at the height of the blue, well, I can see that, again, this 2 is sort of for just this little bit, just from the bottom of the blue, just to the top, that's the height of the blue. And so that height would be 2. And I can do 2 times 5 is 10, times 3 is 30 inches squared. Inches cubed, excuse me. So now I found the volume of the blue one, 30. I found the volume of the orange one, 120. So what's the volume of what we called purple, right? The entire thing. So because they're not overlapping, we can just add these together. We can just say, well, I know the bottom one is 120. I know the top one, the blue one, is 30. So 120 plus 30 is going to be 150 inches cubed. All right? So that's how we can solve something like this. Now, for this next one, we're going to need to put on our math detective badge. Why am I going to need to put on my math detective badge? Because this one gets a little more complicated. Remember, we're still looking for the volume of the entire thing. And let's again call the bottom rectangle the orange rectangle. Let's call the top rectangle the blue rectangle. I'm just going to outline them really quick so that we can see that. Right? And again, if I'm looking for the volume of purple, the whole thing, what I'm going to do is, again, I'm just going to find the volume of orange, find the volume of blue, and add them together. Let's start with looking just at orange. Now again, volume is length times width times height. I see two potential, if we're looking at the bottom on the orange one, I see two potential, I'm going to undo that, lengths. I see this 4 meters and this 6 meters. But if you notice, again, the 4 meters doesn't extend all the way the length of the orange, only part of the way. So I'm going to use the 6 meters because I'm looking for the full length, 6. Width, I see that this says 2 meters for width. And height, well, I see a height here of 4 meters, and I see a height here of 2 meters. Now, if I look at the 4 meters, it's showing that it's actually all of this, orange and blue. And I'm only, right now, only looking for the volume of orange. So I'm only looking for the height of orange. So I'm going to this side where it shows me that the height is 2 meters. So 2 times 6 is 12, times another 2 is 24 meters cubed. Now let's go on to blue, and this is really where we need that math detective badge going on, all right? So if I look at blue, if I look at the blue cube, one of the very first things that I notice is there is no like markings on it whatsoever. I don't see a length, I don't see a width, I don't see a height. But I need to figure it out. And remember that with a math problem like this, it's giving you that information. You might just need to dig a little bit, right? So I can't see it. It's not like just right there, but I can figure it out with the information that it's giving me. So let's look for the length, and then we'll look for the width, and then we'll look for the height. Right? So I'm going to remove this just for a second. So if I look for the length, well, this would be the length, right? We've talked about this before. This is the length. And it doesn't show me length. It doesn't show me length up here. It doesn't show me length here. I can't find the length. But what do I know? I know that the length of the orange one is 6, right? And I also know that this, which extends exactly to the blue, but not further, it does not go into the blue, it just goes right up to the blue, is 4. So this part of the orange box here, the part that doesn't touch the blue at all, is 4. Which means if I sort of drew like an invisible line going down here, then this leftover bit down here, this is 2. How do I know it's 2? Because the whole thing is 6, right? This whole side is 6. And this, everything up to this blue line, is 4. So if I take 6 and I take 4 of it away, what am I left with? I'm left with this little bit. And that little bit is 6 minus 4. Or this whole thing minus this, right? Cutting out this part. And it would be 2. 6 minus 4. So I'm able to infer that the length of this part, just that part, which is what the blue square is, or the blue cube is 2, right? And I can even double check. 2 plus 4 should add up to this bottom number because this whole thing is the same length as this. So if this is 2 plus 4, that gives me 6. I figured it out. This length here, this length is 2. Let's go on to width. Width we had talked about in the previous problem. Because I know that this width is 2, I can infer that this width is 2, right? And last but not least, let's look at the height. Oop, not what I meant to do. So again, I don't see a height. I see a height for the total, the orange plus the blue, that's 4, but I don't want the total. I just want this. I just want the blue square, so I just am looking for this height. Now, as we said before, I know in the orange square, this is 2. This part here is 2. So if this is 2, then I can know that this part here is also going to be 2. So if this is 2, and the whole height, the blue and the orange, is 4, then if this is 2, what's this? 2 plus what is going to give me 4? 2 plus 2 will give me 4. So I can figure out that the height is 2 as well. So now I have my length, my width, and my height. 2 times 2 is 4, times 2 is 8 meters cubed. And so then when I go back to try, now I've got my volumes. I've got my volume of my orange, 24 meters cubed. I've got my volume of my blue, 8 meters cubed. 24 plus 8 will give me my total volume of 32, ran out of room, meters cubed. All right, I'm going to just move this here so that you can see that it's that 32 meters cubed. All right, I hope that was helpful. I know this is a confusing concept. Please stick with it. I promise you'll get it and we'll get it together. Ask me any questions you have. I love you, I miss you, and I'll see you soon.